2.5. And here we're going to be talking about maximum or minimum values of quadratics. Again, we dealt with this a fair amount in algebra 2. Okay, so if I draw a quadratic, that looks like this. And the minimum value would be if I put a ball here or here, it's a point to which it would roll to, which is right there in the middle. This is called the vertex. And because this opens up, this would be a minimum value. All right, now we can deal with a slightly different quadratic, like that. Here my vertex is going to be right there. But this is going to be a maximum value, because this thing opens down. So in other words, anything poised here, if I move it off a little bit, it's going to roll off. Okay, now what we're going to do here is try to find the maximum minimum value. What we do, let's clear up a little bit of nomenclature. Your book has standard form. We were used to this as being called vertex form. And it's really the form I prefer. All right, where H and K are the coordinates of the vertex. All right, and then if you remember, then we dealt with ax squared plus bx plus c as being standard form. Different people will call things different things. I do prefer the term vertex form for this guy right here, for the top one. Okay. Now vertex, remember, is where the maximum or minimum occurs. We just talked about that. There are two ways of doing this. The first way is called completing the square. And yeah, it's that. So let's look at some examples of how to do this. So the first thing you do is you look at a squared, at a term. So if a is not 1, then you're going to need to factor it out. Okay, in our case, a is 1, so we're in a good shape. So the next thing you want to do then is group all terms with an a's. So what we do there is we're going to pop back in here. Now I'm going to have f of x equals x squared plus 4x plus 3. And if I had a number in front of here, then I would want to factor it out of here. And I'll work an example like that. Okay. So now that we've done that, we're ready to complete the square. Because we're interested in getting it into that form right there. But we don't have it. So we're ready to complete the square. By taking half of b term and squaring it. Okay, so there's my b term, it's 4. So half of b equals 2. So now I'm going to come back through, pull this guy up, I have f of x equals x squared plus 4x. Half of this is 2. I will square that. Now, if you compare these two, I've added the 2 squared in over here, so I'm going to want to subtract it out here. Okay? Now we come back in. I'm going to have f of x will be x squared plus 4x plus 4 plus a negative 1. 3 minus 4 is a negative 1. Okay, so now I'm going to factor my trinomial. This one that's in here. And because we completed the square, I've got a perfect square. It's going to be x plus half your b term squared. And you can confirm that these two are the same thing, minus 1. So now we've got this thing in the vertex form. My vertex now is going to be at negative 2, negative 1. Or my maximum value will be where f of x, excuse me, this is a minimum. And the reason it's a minimum is because my a is a positive. So minimum value is going to be f of x equals negative 1. What that means is your function will never fall below that value. The values of your function will never fall below that value. Let's take a look at another completing the square. On this one, we're going to deal with one. We've got a term other than one for a. So the first thing I do is like I did before, I'm going to group okay, I've got a negative 4 here, so I'm going to factor it out. I have a negative 4, that's going to give me an x squared plus 4x plus 3. Okay, so now I take half of that number, which is 2, and square it. I'm going to have a negative 4, have x squared plus 4x plus, again, half of that, 2 squared. I'm going to have plus 3. Now I've added that in, but that is multiplied by that. So what I have to do is subtract out the product of negative 4 and 4. Okay, so now we come through, I'm going to have negative 4 x squared plus 4x plus 4 plus 2 negatives make a positive, 19. And now I'm going to factor this thing. So my vertex is going to be at negative 2 and 19. And the maximum value of my function, and this is now a maximum because this is a negative, so it's opening down. The maximum value of my function is 19. In other words, there's another way to do this. And it involves remembering a little formula. which is that your max or min occurs when x equals negative b over 2a. Now you should recognize this as being from the quadratic formula. Without the radical. And the radical's not there. Okay, so let's go back to our original one. X squared plus 4x plus 3. A is 1. B is 4. So I plug it back in, and my maximum value now, or excuse me, my minimum value, because A is possible, will occur when x equals, and now I plug by points in, so I'm going to get a negative 4 over 2 times 1, I'm going to give me a negative 2. So my minimum value will occur when x equals negative 2. However, that doesn't tell us what it is. So we plug this value back into my f of x, my original one. So to get what it actually is, I'll have a negative 2 squared plus 4 times negative 2 plus 3, which gives me 4 minus 8 plus 3, which is a negative 1. So my vertex then is going to be a negative 2, negative 1, and my max, excuse me, my minimum value is going to be negative 1. If you go back and look, you'll see that this jives with what we did before. Now let's take a look at the second one we did, which was a negative 4x squared minus 16x plus 3. A is negative 4. B is negative 16. And I know in this case, because that's a negative, it's going to be a maximum value because this opens down. So my maximum value occurs when x equals negative b over 2 times negative 4. Or when x equals 16 over negative 8, which is a negative 2. And this corresponds. Now we take this value, we plug it back in up here to find out what our function would be. So f of negative 2 equal to negative 4 times negative 2 squared minus 16 times negative 2. Two negatives make a positive, plus 3. Or f of negative 2, negative 2 squared is 4, so that's going to be negative 16 plus 32 plus 3. This gives me 16 plus 3, which is 19. And that's where my maximum value occurs. Or my vertex then will be at negative 2, 19. And if you go back and check your notes, you'll notice that this agrees with what we had before.